Hello, everyone. Welcome back. We are about to kick off our second tutorial of the day, the Toolbox to Mitigate Bias in AI. So we have three excellent speakers. They're going to be working together to present this one. And I will give them hopefully a proper introduction. So the first speaker is Gabriela de Queiroz. She's a chief data scientist at IBM, leading AI strategy and innovations. She drives the AI adoption across existing and potential customers, leads outreach strategy across our open source ecosystem and data science community. Previously, she was a program director working on open source data and AI technologies at IBM. She's also the founder of AI Inclusive, a global organization that is helping increase the representation and participation of gender minorities in artificial intelligence. She's also the founder of Our Ladies, a worldwide organization for promoting diversity in the art community with more than 200 chapters in over 55 countries. She's worked in several startups where she built teams, developed statistical models, and employed a variety of techniques to derive insights and drive data-centric decisions. Stacey Ronaghan is a data scientist at Amazon, supporting content creation and acquisition decisions for Amazon Studios and Prime Video. She previously worked as a consulting data scientist for IBM, identifying opportunities and building AI solutions for clients across industries. Stacey has shared her expertise on AI fairness and AI explainability through client projects, presentations, blog posts, and contributing to open source packages. And finally, Saishruthi Swaminathan is an advocate for trustworthy AI and an advisory data scientist at IBM. She's a master's in electrical engineering, specializing in data science, and a bachelor's degree in electronics and instrumentation. Her passion is to dive deep into the ocean of data, extract insights, and use AI for social good. Previously, she worked as a software developer. She's on a mission to spread the knowledge and experience she acquired in her learning process. She also leads an Education for Rural Children initiative and speaks at meetups focusing on trustworthy AI and women's empowerment. We're very excited to have these three, and I'll turn it over to Stacey to kick us off.
Thank you very much. All right, so our title of our presentation is Toolkit to Mitigate Bias in AI, and I'm going to first give you some kind of foundational background material on responsible AI. Then Gabriela and Saishruthi are going to talk about AI Fairness 360 and dig into some of the things you can do with the tool, how you can use it with R. And then Saishruthi is going to have a live demo where we hope to kind of walk you through how you would utilize this tool and kind of explain some of the things that we're creating and doing in that tutorial. So let's kick it off with some foundational stuff. So we know AI has a lot of opportunities. We interact with it every day, whether it's navigating to a coffee shop, to the office, wherever we go now in our cars, whether it's sitting in front of the TV and being recommended what content to watch. So as consumers, we really enjoy it, but also companies get to use it to make themselves more efficient. Maybe they're improving their business by providing better recommendations, or they're making manual tasks automated to kind of reduce kind of cumbersome activities that staff have to do. So generally, the two things on the business side of things tends to be increased revenue, making more money, or efficiencies tending to save time or save money. Although it's great that we have AI and we're utilizing it to do these wonderful things, it also comes with some risks. So there can be harms to users. So particularly if you're building something that interacts with a human, whether that's making those recommendations or deciding whether a loan should be accepted or not, there's a risk here that we can cause economical or opportunity harm where we might be discriminating between different groups. And this is something we want to make sure we're not doing and mitigate. And there also can be the harm to the business. If you're building an AI model that's not accurate, it's not performing as you expect, then you're not going to get those increased revenue or efficiencies. And of course, if you're harming your users, they're not going to want to use your product, and your brand is going to suffer from it because you're doing something you shouldn't be. The good news is we're trying to highlight here some possible solutions. The first one is regulation. Now, this is tough as an individual because a lot of this will come through policies. And we do see a shift here, particularly with things like GDPR in Europe, where we're trying to look at these solutions and try and make them more transparent in terms of how they're being used and make them more explainable. And more of this will come. As individuals, we can look to those policies, make sure we're voting on the right things to kind of help make this more regulated, the space more regulated. But for individuals within our companies, and when we're doing data work, we can align with ethical and moral practices. So we're going to talk about some kind of tools and techniques and things we can think about in this presentation. And that could be, you know, companies creating these ethics boards. So if you have a question, you have somewhere to turn to. It's also utilizing things like the toolkit we're going to talk about. So one of the main terminologies that I want to discuss is unwanted bias. So as a lot of mathematicians, statisticians that might be, you know, watching right now, bias is something we consider and can be something we can utilize, exploit. But unwanted bias is not the case. And what this is when we're talking about a privileged group and an unprivileged group that are systematically advantaged or disadvantaged. And so this could be, if we're looking at gender, this could be males or men tend to be privileged within society historically, and that kind of mitigates through our data, which we'll talk about in a moment. And they have a systematic advantage because historically they have done so, and that kind of continues going forward. So these are some terminologies, and we'll go a bit deeper into it. But ultimately, we don't want to have groups based upon things we can't control to be aligning with whether or not we get a good outcome. So we want to prevent this advantage to privileged group and disadvantage to unprivileged groups. So I'm going to go over the slide. It's quite comprehensive, so I will try and keep it as short as possible. There is a link here to the paper. Thank you, Saishruthi, for sharing this with everyone. I do recommend reading it. It will also go into a lot more detail than what I'm going to talk about in terms of examples of each of these types of bias. And so the top portion, we're looking at data generation. So we get our data from the world, whether we're interacting with something and it's saving and logging our behavior, whether we're, you know, capturing it manually through surveys, whether it's you reading books and novels and, you know, pulling in that textual data, audio, video, things like that. So we take what's available to us and that becomes a data set for us. And then we might be sampling it, we might be manipulating it into a data set. And then when it comes to AI and machine learning, we do that model building and implementation, where we take that data and we split into training and test data, and we're going to build a model. And then that model gets used in production. It's going to make some predictions, do some output, which might be, you know, a human sees that and make a decision, or it might be automatically producing ads on your web page, for example. And this is all deployed into production and being utilized by us in the real world. So the different types of bias that we touch on here are historical bias. So what I mean by this is just how things have been in the past. And because we're collecting data, it's not all from today, it's from, you know, decades, generations of data, then this can capture things that may not stand true today. And so a good example of this is when we do natural language processing and something called word embeddings, where we're creating numerical representations of words. And what we find, unfortunately, is that the word nurse is more closely aligned to female, whilst doctor is more closely aligned to male. So maybe historically that is a gender norm within these roles, but we don't want to keep that going forward. So being aware of historical bias and looking for how that is in our language, how that's in our data, we can think about how we want to move forward with that, how we want to mitigate that. Then we have a representation bias. So this could be whether you're sampling for your product and you only sample in one neighborhood and you don't go outside of that, well, you're not going to be able to learn the patterns of people outside of that one cohort that you've looked into. It could be unbalanced data. An example in this paper is people who are pregnant. If we're building something for the general population, only a small proportion of the population are pregnant. But if they require different things for our product, because it might just be like, oh, we get it right for the majority of people, we're excluding the patterns and behaviors and requirements of those that are pregnant. So we need to keep that into consideration. Measurement bias is usually when we create a proxy for something. So we can't capture the real truth and the real thing we want to predict. So we use a different value instead. Again, an example mentioned in this paper is predicting whether a student will be successful at school for college applications. Well, we fall back on GPA, and GPA is known to be biased. The more affluent you are, the more money you can put into your preparation, therefore, the more likely you are to get a good result. So consequently, using a proxy can cause some harm as well, and we need to consider that. And also then in learning, so now we're kind of looking into building a model. This is a point where we need to decide what is that model optimizing for. And so maybe you want to optimize your application or a website to be engagement. You want people to use this as much as possible. You want them to read all the blog posts, you want to watch all the videos, and you find the best way to keep people engaged is showcasing clickbait. And so they're now following the clickbait. And this is kind of where we lead into polarized views and like bubbles on social network, or we go down some like rabbit hole into some conspiracy theory, because it's just going to find you the most enticing, or like, it just trigger you into wanting to know more. It doesn't necessarily mean that that content is factual or going to be beneficial to you. So there's a trade-off here with optimizing for engagement, but maybe it's a loss of happiness for your customers, and their experience is having a detrimental effect. Then we move into our evaluation bias. And so what we mean by this is a good example is gender shades. I don't know if you've come across this, where when these face recognition models were being built, they were built on predominantly white and male data set. So they've been tested, being validated, like, yes, we're getting great accuracies. And then when they got sent out into the real world, well, everyone was starting to use them. And the darker skinned individuals, the darker skin you had, the less likely it would recognize your face or gender you or age you. Or, and also, yeah, particularly for dark skinned women, this was very problematic. So when you're thinking about how you're going to evaluate your model, you really need to think how it's going to be used, who it's going to be used by, and maybe evaluate across groups if there is a chance of any form of bias in your product. And then finally, we have the deployment stage. Oh, wait, I missed aggregation. I apologize. So aggregation is kind of this, you're building for the majority. So you just kind of like grouped everything together. You've aggregated to kind of a higher level. And so you might miss the nuances or behaviors of groups that you've kind of rolled up. A silly example here for me is about my baking. I'm British. We have a smaller population than the US. And if you tell me that my baking is quite good in America, apparently that's a compliment. In the UK, it is not. So in terms of the sentiment of that statement to me, it differs depending on like my context. And then finally that deployment. And this is where there's like a mismatch between what a bot model has been built for and what it's being used for in reality. So an example here is a model that was built for the cost of care. So how much do we expect this person will cost in terms of healthcare? And then it being used to predict their healthcare needs. Well, generally, affluent white people are spending more money, getting more healthcare, going to be costing more. It doesn't mean they are more likely to need help than their counterparts. And so it's really important to not just take a model and put it into production. It's close enough. You need to think about what are you actually testing for? What are you trying to achieve? And make sure it really does align with that. So the points I want to leave you here, though, we potentially have some bias in our data. We could have some bias in our model building, or we could have some bias in the model output, because we'll come back to that later. Okay, and so the good news is we're giving some tips here of like things to think about when you're building out this pipeline. So this is called our responsible AI pipeline. And it goes from the data model we've already talked about on that last slide, but also kind of when you're thinking about designing what you're going to build, when you put it in production and you're monitoring it, and just generally thinking about accountability. So within the design side, ultimately, we want the product to be human-centric. We want to think about our users, maybe not just the initial users we're going to think about, but everyone that could possibly use it, and make sure there aren't any nuances there that we need to consider. We want to build something that satisfies people and makes people happy. And then coming back to the optimization metrics where I said, engagement might be detrimental to the experience of your customers. We need to be careful of that. Like, what are we optimizing for? Why does that align with what we want? What are the kind of caveats and things we need to think about? And maybe there's multiple metrics you're optimizing for, and you want to think about that. So the data, we talked about representation bias, so making sure your data is representative. You want to make sure you're capturing everyone that you can. And also protected. I'm talking about here, it's not really within what we're going to talk about later today, but just generally, if I'm sharing my data with you, and it becomes a bit of a currency in today's world, but I'm expecting you to protect my data. I'm expecting to, I get a lot of notifications of leaks. So I now have my password control, lots of obscure passwords, but, I want to trust the company that I'm sharing my data with is going to use it and keep it safe. And so that's another thing to consider. Modeling, the two things here are interpretability. So is it explainable? So particularly with like neural networks, they can be so complicated and they have these great results. But as soon as my client's like, oh, why is it doing that? I'm like, oh, okay, let's work that out. And so we need to be able to explain the why. And there are tools, there's a kind of sister tool to AIF 360 called AIX 360, AI explainability, which is trying to mitigate that sort of circumstance. But it's very much, we need to give the why. We need to give the why to when people are building the models, like not only is it accurate and performing well, but it's intuitive, it makes sense, it's not doing anything obscure that we wouldn't expect, so that the business folk can understand it. But also as an end user, if you tell me I can't get a loan in a bank, I hope you're going to tell me why. I need to increase my credit score. I need more money in this bank account. Give me something actionable rather than just be the algorithm said so. That's not good enough. And then fair. So this is very much what we're talking about today. But how can we make sure we're not building something that does have that bias, unwanted bias? It is harmful to our users. We want to capture that and make sure we can mitigate for it. So the monitoring, this is, we've built a model, we're happy with it, it's interpretable, fair, great performance metrics, let's push it out into the world. Well, the caveats here is you don't want to push it out and then everyone's using it and everyone's having a terrible time. So let's be cautious about how we roll it out. We do want to roll it out to that representative audience to make sure that if there are any harms, we're able to capture that and we're able to mitigate it and roll it back. Do we have an emergency stop button if it is performing unexpectedly? We don't want to leave it running and not be able to fall back on our prior product or prior thing that we were using before. And then the feedback loop. So that could be, it could be monitoring our metrics to make sure it's still performing well because data changed over time. Our accuracy metrics will drift. Also fairness, are we still being fair moving forward into the future? Or it could be a human in the loop. Do we send some examples to be audited? So these examples that we are less confident in, or there's a higher risk of being unfair or whatever, do we pull a human in to give us that feedback where there could be problems? And again, push that stop switch if we need to. And the final one is accountability. And this is kind of just transparency. So this is transparency to your customers. What are you using their data for? Do you have permission to? Things like that. But also internally as well, like in that design phase, what did you flag up? How have you accounted for it? If an external company came in and audited you, what could you present to the business? Is it something someone built, they left 10 years ago and you're still running it? That's not okay. So transparency of how this is working. And then responsibilities, who owns it if it does have a problem, who owns what? We don't want to just ship things out and then that's it, we don't touch it anymore. It's not our problem, we built it. So making sure it's really clear who does what. So, yeah, you can build the best product, and if there is a problem, you can come back and work as a team and collaborate to make sure it's fixed. And then my final slide is just kind of a summary of why we need to care about this. So ultimately, we want to prevent harm. We want to be building inclusive products. We want to make sure they're delightful to our customers and not just for a niche market. We want to make sure they're welcoming and they're not excluding anyone. And then responsible branding. My thing about this is I don't want companies to do this because they can do a PR on it, press release on it. But at the same time, to me, this is like buying a Tesla because it's cool, but the downstream implication is still you're using less fossil fuel. So, okay, the goal of doing it isn't ideal, but the downstream implication is good. So ideally, I want it to be for the top three, but also with a responsible branding as well. I hope the companies share a bit more about how they're looking into these subjects, how they're working to become better to promote these sort of things. So we can collaborate and share ideas. So rather than it being kind of whistleblowers that come and say something bad has happened, we're proactively sharing what we're learning in the business. All right, so that's everything from me. Hopefully that's a good foundation to move you forward. So I'm going to hand over now to Gabriela, who is going to talk you through our toolkit.
Thank you, Stacey. And you can keep sharing and I'll ask for the next slide. Okay. Yeah, so that's easier. So hello, everybody. I have to tell and say that I'm very excited to be here because you are my favorite people. I don't tell this to everybody, right? So this is very special. I'm so excited to be here. Maybe in the few years I can be in person. And I'm so excited to be talking about this toolkit and yeah, thank you. I'm beyond thrilled to be talking with you all. So anyway, so like I'm going to be talking about the AIF 360, the toolkit that we have that it's open source. So let's go to the next slide, Stacey. So the AIF 360 or AI Fairness 360 is this open source toolkit for measuring, understanding, and reducing AI bias. It combines several metrics and also like bias mitigation algorithms, some metric explainers from several researchers across the industry and academia. So this toolbox, this package was implemented using techniques from different published papers, and it's available in Python originally, and then it's now available in R as well. But before that, let's go to the next slide. Before we jump into the demo and to more hands-on, it's important to understand some of the terminology because we are going to be using this across the examples that we are going to give. And sometimes this terminology can be a little bit tricky. So I just want to make sure that we are on the same page, understanding this terminology. So let me guide you through some of the terminologies that we are going to be talking moving forward to the next slide. So the first one is around favorable label. So it's a label that the value corresponds to an outcome that provides an advantage to the recipient. So such as receiving a loan, being hired for a job, not being arrested, etc. The other one is the protected attribute. It's an attribute that partitions a population into groups whose outcome should have some kind of like parity. So it could be race, sex, religion, etc. The other one is the privileged value of this protected attribute. So it indicates a group, as Stacey was mentioning before, a group that has historically been at this systematic advantage. And then the next one is around discrimination and unwanted bias. So it's when a specific privileged groups are placed at this systematic advantage and specific privileged groups are placed at a systematic disadvantage. So let's go to the next slide. And this is also like, just to mention, if you ever confused, and I get confused all the time with all these labels because sometimes it's not very clear what they mean. I always go back and I'm like, oh yeah, this is what it means. So this is an example where on a loan app, like there is this loan application and they are looking at like different attributes. So in this case, the favor label would be no credit risk. The unfavorable label would be the credit risk. And then in this case, the protected attribute would be sex, and the privileged protected attribute would be male. This is going, again, to be more clear once we go through the example, but just to make sure that we are on the same page, because in the code itself, we are going to be defining those variables as well. So next slide. All right, so now I'm going to pass to Saishruthi. She'll take over to the next step where she will be talking about the metrics and then going to the hands-on part.
Awesome. I'm going to share my screen now. Thank you, Gabriela and Stacey, for awesome introduction and overview of the toolkit. So I'm going to share my screen. I hope you all can see the screen now.
It's perfect.
Awesome. So yeah, hi everyone, and as everyone said, I'm so excited to be here, and gratitude, from our end for joining us today, because time is the most precious thing, and thanks for giving your time and and coming to our presentation. So I'm just hearing some random noise in my from my computers. I'm going to turn off my video so that the presentation goes smooth. I hope it's okay. So yeah, let's start with the toolkit components, right? Like, what is there in this toolkit? So AI Fairness 360 toolkit can be used throughout the AI application lifecycle. So by this, I mean the toolkit can be used to detect bias in training data as well as in the trained model, and mitigate detected bias in the data used for the training the model, and even in the model being built, also on the built model, right? So that's what we are going to see now. So I'm going to highlight. First, we are going to start with this pre-processing phase. So we get the raw data, we clean and process it, right? Then we can use the AF 360 toolkit to see if the data set has any bias. If there is any observed bias, we can use pre-processing algorithm to mitigate the bias. From here, we take the transform data set, as you can see the screen, and take the transform data set to build the model. So this is the pre-processing phase. Next is the in-processing phase. Again, we get the data, clean, process it, then we use the toolkit to see if the data set has any bias. And if there is any observed bias, we can use in-processing algorithm to build a fair classifier model. And the point to note here is, here we are not transforming the data set, we are not touching the data set here, but we are mitigating bias when building the model. And then the last phase is called the post-processing phase. Again, we get the data, clean, process it, and we build the model. Then we use the toolkit to see if the model that we have built has any bias, right? From the validation to SIL, from the prediction, we infer if there is any bias. And if there is any observed bias, we then use the post-processing algorithm to mitigate bias in the built model, right? And again, the point to note here, we are neither transforming the data set nor building model using the toolkit, but trying to mitigate bias after the model is built. So these are the three phases, and you can use this toolkit throughout the application lifecycle. So now let's get one level deep, which is metrics. As mentioned earlier, the toolkit has over 70 metrics to quantify unwanted bias in the data and model. So we'll start with a high level grouping. Right? First, let's start with the group fairness. So on high level, we have two types. One is the group fairness, and the second one is the individual fairness. I'm going to go a bit slow so that it's clear. So what do we mean by group fairness? So as Gabriela mentioned about the protected attribute, right? So here we are going to use the protected attribute to partition our population into different groups, and then we look for some statistical measure to be equal across the group. So this is a definition, but let's visualize it. Let's see how it works. So this is the visualization I got. I hope you all can understand from this. So the top box is the entire population, right? The complete entire population. And the orange and white are like two groups based on our protected attribute. So our protected attribute, for example, in the previous example is sex. So based on sex, we divide the entire population into group. So the group 1 is the sex 1 and it's all in the orange color, and the group 2 is the sex 2 and it's all in the white color, right? So what we're trying to do is, using the metric, we are trying to see if they all are equal, right? If they are being treated equal. So that's the metric that's available under the group fairness section, like on a high level, what the group fairness tool has. And then the individual fairness. As the name says, we seek similar individual to be treated in a similar way. So the protected attribute, for example, there shouldn't be any discrimination based on sex, gender, or so on, right? We don't want any discrimination based on the protected attribute. And all the individual with same feature value should receive same predicted outcome, the predicted label, and individual with similar features should have similar predicted label, right? At the end of the day, we want the same individual, like similar individual, to be treated in similar way. So now that's the definition. So this is like the visualization for the individual, fairness. The box, again, it has the entire population. I try to differentiate individuals based on color, right? So I have this white color, blue, and green. So they are like similar individual, and we can use the individual fairness metrics to make sure that these similar individuals are treated in a similar way and they're not getting discriminated based on the protected attribute. In our case, for example, it's sex, right? We don't want any discrimination to happen based on our protected attribute. So by similar individuals, I mean like the blue color and the white color and the green and the brown. So this is the high level classification of the metrics. Now getting one step again. So under group fairness, we have different classification of metrics. The simple one is the data versus model. We can measure fairness on the training data as well as we can measure fairness on the learn model, right? So this is pretty clear and straightforward. We can measure fairness both on data as well as on the model. And this is an interesting classification as well. And I have highlighted in purple, it's like we are all equal versus what we see is what you get. Sorry, what you see is what you get. So I'm going to explain this again with a visualization. Like, first, let's start with what you see is what you get. So we have two people here and with different SAT score, right? Let's take an example of SAT score. So consider a person with score 900 and another person with score 1400. So based on this view, this what you see is what you get view, person with score 1400 is considered to be more successful than person with score 900. It's like you see the score and you decide the ability. Whereas in we are all equal view, we don't care about score, right? We believe everyone has the same potential to do a specific task, and the score, the score doesn't really reflect the ability. So this is another interesting classification of metric, and the toolkit also has metric that can cover this type of cases. So, so these are the list of group fairness metrics and individual fairness metrics. You can actually go to the documentation and then get all the list of like 17 metrics that's available in the toolkit. So the next thing is the fairness tree. Before getting into fairness tree, I just want to give you like another quick example for the group fairness. Let's say our population count is 20 and we have split the population into two groups, right? I'm trying to, just take the example that we had before and try to convert this into, visualization here. So in the privileged group, out of 10, we have 7 people receiving the favorable outcome, And in unprivileged group, out of 10, we have only 5 people receiving the favorable outcome. So the two group fairness metrics we are going to see here is statistical parity difference and disparate impact ratio. In statistical parity difference, we compute the difference of the rate, right? The favorable outcome received by the privileged group, sorry, unprivileged group to the favorable outcome received by the privileged group. We calculate the difference. So as you can see here, I'm calculating the difference between unprivileged and privileged, which is 5 by 10 and minus 7 by 10. And it's minus 0.2. And the fairness range for statistical parity difference, that's a common fairness range, and it can vary based on your application, is between minus 0.1 to 0.1. And you can observe that slightly, not in range. And the other metric is the disparate impact ratio. Here, instead of difference, we compute the ratio. And the fairness range, again, the common range is between 0.8 to 1.25. And, it's if it's like less than 0.8, then, we consider to be not fair, right? So we have 0.714. So this is how it's been calculated internally, and with the toolbox can handle, all the input, and you can use the documentation to learn how to use the toolbox, and we'll show the demo as well. So, and the next thing I want to, cover is the fairness metric tree. I don't want to overwhelm you all with, all the cases here. I'm not going to, go through each and every case, but I'm going to pick one so that when you go back and try to navigate through this tree, you should be able to, understand it easily. So let's go back and connect with the credit card approval example. So first, we need to think if we want our system to be fair in terms of the error or in terms of representation. Let's say I care about error, right? I care about the system error. The next step, we want to focus on errors that can hurt an individual, or we want to focus on errors that can help an individual, right? So, and then in this case, let's say I want to make sure that my system doesn't deny an application because of bias. In reality, if the application has no red flag, but just because of just because my system is biased, the result is also in the unfavorable side. So I want to prevent this application from getting rejected, right? So I care about, I want to help the individual and not to, hurt an individual. So I can just navigate the tree that we have here, and we can pick the metric and evaluate if there is any bias. So I hope it's not too much of information, and we are there in case you have questions. I'm sorry to put everything into squeeze all this topic into 10-minute presentation. So we are happy to help you in case of questions. And next is the algorithm part. Now that we have detected the presence of bias, right? Now we are moving towards mitigating them. So this bias mitigation algorithm, it attempts to improve the fairness metric by either modifying the training data or learning algorithm or prediction. So they are basically categorized into 3: pre-processing, in-processing, and post-processing. There are about 10 algorithms in total. So the pre-processing, under pre-processing, we have 4. The ones that are highlighted in red are available in our version. So basically how we deal with the data is, on a high level, the mitigation is done by formatting the data set with additional data points, and we apply instance weight, like we give weight, a different weight to different data points, so that we make sure the groups are treated fair, and by altering the training data labels, right? So these are high level, ways of mitigating the bias. And the next is in processing. Here we deal with model. By model, of course, is we want to make sure the predicted attributes are not impacting the prediction result. And we can change the regularization term, we can optimize for the fairness metrics, and we make sure the learning objective is aware of the discrimination. And the last is the post-processing. Here we deal with a prediction label. We can update the label and use this algorithm and make it fair. So the place, for example, where you will not have access to data and training the model part, right? For example, if you're purchasing a pre-trained model from a vendor to include in your pipeline, you may not have access to your data or to your, the model building phase. So at that time, we can use algorithm from the post-processing and then try to mitigate the bias if there is any. So I would like to, end with the choice of algorithm. It depends on where we can interfere in the machine learning pipeline. If you have access to data and can modify data, pre-processing can be used. If you're allowed to change the model, then in-processing can be used. And if user can only treat the learned model as a black box without any ability to modify data or model, then post-processing can be used. So we recommend early intervention if that's the best, and if possible, all the algorithm from all the permissible categories should be tested, because end of the day, there is no one algorithm that's independent of data set, right? It all depends on the data. So we recommend early intervention in the pipeline. So with this, I'm sure you're all waiting for the demo. So Gabriela, now it's your turn.
Thank you, Saishruthi.
Yeah.
Let's go to the next slide. Sam, I know that you have a few questions. If you don't mind, let me just finish this next set of questions before we go into the live demo, and then we can answer some questions. So Saishruthi, do you mind you can keep sharing the screen, and then we'll take some questions before going to the hands-on.
Sure.
So yeah, so the package, the R package, the AI F360 packaging. So there are two ways that you can, well, actually more than two, but two ways that you can use this package. So you could install in your machine, or in our case, we also provided instructions on how to run from Docker. There are some advantages of running on Docker. The installation can be a little bit tricky because, not because of R, because we are using the package, the reticulate, that it's kind of like wrapping around the Python original version. So there are a lot of sometimes errors that you can get that is not because of R, but because of the Python piece. So for this demo, we are going to be using the development version that we have on GitHub. So if you haven't installed yet the whole package, I would recommend you to try Docker, because it's like you install Docker and then you run one command and that's it. But then later on you can install in your system. Let's go to the next slide, Saishruthi. So the use case that we are going to approach for this demo is like this. So the business use case. So we want to select customers who are likely to buy this new product. And the target audience is going to be people whose income is over $50,000. The data set is a well-known data set, the adult data set, and there are several attributes like age, education, occupation, race, sex, etc. And all the examples that we are going to go through, they are going to be based on this data set. The data set is publicly available, so you can also use in your project, so you have no issues with licenses. The scripts are also in our GitHub repo. The slides are going to be uploaded there in a bit. And next is our live demo, where you can follow along or just follow us and ask questions as we go. And I think that should be just a good time, Saishruthi and Stacey, for just to get a few questions and to answer some questions before we do the deep dive. So Sam, I think you had one question. Do you wanna?
I was also tagging in the chat. I can press send. Or ultimately, I mean, theoretically, you can include any attribute in the similarity, the distance metric that you want to create. The problem of including any of your protected classes is it could be deemed acceptable and fair to be treating someone of that class this in a bad way because you treat them all the same. And worse still, if it's intersecting groups, then again, yeah, you could be treating them even worse than just, someone that's a member of one protected group because you're treating them all the same. So it's not recommended in that sense. And it's very much in the business use case. It might be more, I don't know, are you giving similar people, I'm trying to think of one that's less controversial that might not, if you don't have access to protected attributes necessarily, but you expect similar people to be treated similarly. I'm trying to think of good examples, so hopefully I'll come back to you on that. But when it comes to all of these things, the good news is, same as when you're optimizing for a machine learning algorithm, you don't need to optimize for just one of these groups. Downside is there's a very big paper on how none of these fairness metrics kind of work nicely together. So if you are using more than one, there is kind of a trade-off between them you need to consider. So similarity, I need to find some good examples, and team, if you can think of good examples where it can be used, let's come back with those. But anything with protected, you don't want to say, oh, well, I treated all these people of multiple groups the same, therefore it's fair, because it's not. So you do want to be looking at group fairness if that's the thing that you're concerned about. I'm going to press enter on this in case my text was more concise than what I just said to you.
No, that makes sense. And I think that, intuitively makes sense to me as well. Because I mean, if you want to make sure people are being treated fairly, but you also want to make sure you're not discriminating against protected classes, then it makes sense that you wouldn't want to include protected class information when you're comparing similar individuals.
The example that I thought about was, if you're putting people up for promotion, are they similar in some way or something? But again, there's loads of protected classes that could be problematic in that space. So I'm trying to think of a space that's kind of detaches a little bit from protected groups.
I work a lot in the insurance industry. We're doing actually a lot of this right now. So I would love to talk to you, separately about our use cases for all of this stuff, because this is why I'm here, is for this tutorial. So yeah.
Wonderful. Well, we'd be delighted to chat with you. That's
awesome. All right. Thanks.
So while Saishruthi is getting things running, I just want to reiterate that the instructions they are on our GitHub or the conference GitHub repo. And if there is any error that you get, feel free to get back to us saying, oh, I have no idea what you're doing, or like there is this error, can you help me? That we will try the best we can to help you.
Awesome. Sounds good. Thank you so much. And now getting into the demo part, right? So we have instruction in the repository, which will walk you through the installation process. And we recommend, creating like a separate environment using Conda for this purpose, for the purpose of demo, so that the installation is clean and there is no conflict with the other Python version or other package versions, right? So that's the reason we recommend installing in a separate environment. So once you go through all the instruction, at the end we finally load the library. Once we are done with the installation in our environment, we load the library, and then we start the demo and we start the example scripts. So I'm going to go through the example script first. And when you're actually getting into the demo part, we can help you if there is an issue with the installation. So I have my library loaded already. So I'm going to start loading the data. Here we are using the UCI adult data set. And I'm displaying first few rows of my data set. I hope you all can see. Let me just try to increase my screen space. And then I'm defining my protected attribute, right? So protected attribute is what is used for partitioning the population into group. So here our protected attribute is sex. And now we are defining our privileged group. So the privileged group by definition is the group that has historically been at systematic advantage, and we need to provide the protected attribute, and the value of a protected attribute we think will fall into the privileged category, right? So here one indicates male, so we give protected attribute 6 and 1 as an input to our privileged group, and then we declare unprivileged group. So the value 0 of protected attribute 6 will be the unprivileged group, and we give that as an input here. And the next step, we convert the input data frame into a format that AFNS 360 toolkit can take it, right? So there's a specific format that the toolkit follow. So we need to give the data set, favorable label, unfavorable label, privileged, unprivileged group information, what is the target column, and what is our protected attribute. So we need to provide this information so that we get a data set transformed in a way that the toolkit can use. And then I'm splitting the data into train and test as usual. So on the next step, so this particular demo, we are going to focus on the pre-processing phase, right? So I'm going to test if there is any presence of bias in my training data. So I'm going to use statistical parity difference metric to see if there is any sort of bias that exists in my data, right? So the metric range is from -1 to 1, and the ideal value for the metric is 0. And the acceptable fairness range, right? Like the acceptable fairness range for the metric is generally between -0.1 to 0.1. But this is not the fixed range. You need to make sure what is the application is about. We need to know the business objective, and the threshold can vary based on the application, but this is the general fairness range. So I'm initializing the dataset metric class, and then I'm accessing the metric, and the value that we're getting here is -0.1932, and it indicates there's a slight bias in the dataset based on our metrics range. And now we are getting into the mitigation part. Right now we have detected presence of bias, and we get into the bias mitigation part using the pre-processing phase. Again, this data set doesn't reflect the real world. So we got this data set from the UCI, and you can try and test out the different combination of the split to see how it works. So the algorithm that you're going to see today is the reweighing algorithm. I'm going to give you all a high-level overview of this algorithm, like what it does. So this is based on the fairness criteria independence, right? So what we do is we typically take the data and then categorize them into different groups. And after categorizing them to different groups, we make sure that they all the outcome is statistically significant and the group doesn't reflect the outcome, right? And based on that, we kind of change the weight of the sample. If there is any bias, we change the sample data sample weight to make sure the groups are treated equally. So this is the high level overview of how the algorithm work. So I have a simple, I took like a data point with just data set with just 5 data points, and then tried to derive how the algorithm works. I'm not going to go through it. I have them in GitHub. So I kind of derived each and every step of how the reweighing algorithm will work. For the simple data set, if you can understand with just 5 data points, the same applies for, even if you're working with million data point, data set with million data points, right? So I have this in my GitHub. I will post link to it. But yeah, so on a high level, it changes sample weights. So here we are trying to mitigate using the rewiring algorithm, and the outcome is the transformed data set. It's a bias mitigated data set. But then we can't be 100% sure, right? Like we can't say, okay, now I gave input data set as an input to my algorithm, and the output is always the mitigated data set. So you want to make sure if some mitigation has been done. So we check the metric again, and this time you can see, it has tried to remove as much as as possible. Again, this data set doesn't reflect the real world. So the goal is to show you all how the toolkit works, right? But yeah, there is a bit of mitigation that has happened using the rewiring algorithm. So this is our pre-processing. On a high level, you take your data set, you convert them into a format that AF360 toolkit can take, and then we are using the group fairness metric, statistical parity difference, to see if there is any presence of bias. And then we use the reweighing algorithm, mitigation algorithm, to transform the data set by altering the sample weights. And then we are checking again if the mitigation has been successful or not. So that's the flow of the script. And should we go one by one, or do you all want to try and then go to the next one?
I would say see if anyone has any questions before moving to the other one. Yeah, one thing that I want to highlight here is, like, we try to write a lot of comments to make sure that we are explaining what we are doing, because we know that the content can be a little bit hard to take all in at the same, in one go, like in one session. But at least exactly the things that you need to follow to get to a place where you are comfortable enough. So I would say, let's go to the second one. But I have just one question, Saishruthi. Why? Because one is the pre-processing, and the other one that you are talking about is in processing. In our analysis, do we need to do both, or do we need to do one? Like, why, for example, in this case, we have two. One, it's like the pre-processing, and now you are talking about the in processing.
Yes, so we want to make sure which, first, again, it depends on where you can interfere in the pipeline, right? Now for demo, I'm able to show both pre-processing and in processing, but in the real life scenario, you may not have access to the data, right? You may not have access to the model building phase. So that's when we should decide on the algorithm type, like which algorithm should I use, like which algorithm should I go for. And the second aspect is, if possible, it's also recommended in the guide, we should try and see which algorithm works better for the data set, right? There's no one particular algorithm that will work independent of the data set. So we want to make sure, if possible, try as many algorithms as possible to see if which way of mitigating the bias is working good for the data set. So that's the second point. So for the demo, yes, we have access to training data, we have access to the model building phase, and we really care about only the group fairness on a high level. But in real life scenario, let's say you want to care only about, we are all equal view, right? We only want to care about what you see is what you get view. So based on our objective, based on our notion of fairness, the algorithm choice can vary. And we have a detailed guidance on how to choose algorithm based on notion of fairness in the AF360 website under the guidance. If you go to the end, we have a clear explanation of how notion of fairness can help you choosing the algorithm. So getting to the next demo here, we have in processing, right? Now, you all, I hope you all understood how to use the pre-processing algorithms and how to, check for presence of bias. And next is in processing. So again, the steps are going to be same. We are going to assign protected attribute, privileged group, unprivileged group, and we are going to split the data. Everything is going to be same till the metrics, detection, like using statistical pattern difference metric to detect if there is any presence of bias. And now we take a shift, right? In pre-processing, we provided the input data set to our algorithm, and we got the transform data set with the bias mitigated transform data set. In this case, we're not going to change anything. We're not going to change our data set. We are going to give our input pre-processed data set directly to our in-processing algorithm. So the algorithm that we are using here is adversarial debiasing algorithm. So on a high level, what it does is, okay, there is an original model which is trying to use all your data set feature and trying to predict your label, right? So that's what in general it happens. You build a model which is going to take your input feature and then predict a label. And in this adversarial debiasing algorithm, there is another model called adversarial model. What it does is it's going to take your label and then it's going to see if it can predict your protected attribute, right? So on one end, we are using a feature and trying to predict a target. And there is an adversarial model which is going to take your target information and trying to see if it can, predict your protected attribute. So if it can predict your protected attribute, that means, the outcome has some dependency on it. So the entire adversarial debiasing model will try to maximize the accuracy of the prediction, but simultaneously reduces, the effect of protected attribute on your outcome. So that's what it does. There is, imagine like a two model trying to do back and forth thing. One predicting label from feature and other trying to predict protected attribute from your label. So that's what it does. So we are going to fit the model. It's using TensorFlow in the backend. So what it does is it's going to train a classifier for us. Once it's done, we are going to get the prediction result, and we are again going to evaluate, see if there is, reduction, if the bias is got reduced, right? It got mitigated. So our first value here is minus 0.1932, and the second value here is minus 0.08. There's a bit of a shift in our bias, in our fairness value. And again, now imagine, right, like now we have tried both pre-processing and in-processing. You can actually take this and put it in a table and try to see which is working better. To answer to Gabriela's question before, at least it's one of the recommended ways. Imagine like having a table where you test, okay, this is an in-processing result, so this is your pre-processing result, and trying to see which works better for your data set. And it should match with your notion of fairness, like what is fairness for your application. And based on that, you can pick and choose and play with the toolkit algorithms and metrics. So yeah, so now y'all can get started. I guess we have instructions pretty clear in terms of the installation, and we have the scripts in the repository as well. And we can get started. And if there is any question, we all can do together.
Any question, anything that you want to bring up? If not, we have more to say.
Yeah.
Sam, we got a question. Sam. Do you want to talk or do you want to write?
Hey, yes. Okay. So my question is about like intersectional metrics. So if suppose you want to look at race and gender combined, how would you do that?
Yes, so that's a great question. So I mean, when I started in getting used to the toolkit, I had the same question as well. So the proposed or the recommended way is to create a feature which is a combination of both, right? So that's a recommend. For example, race 1 and gender 0 will be our privileged group, right? We can create like a variable, like a feature which is a combination of both. Like if it's 1 0, then I give 1. If it's 0 1, then I give 0, right? So the recommended approach is to create a variable which is a combination of both, but the toolkit can also handle multiple protected attributes, right? So the toolkit by itself can take more than one protected attribute and try to group them into privileged and unprivileged group and handle the scenario. The other way to do this is also creating a new feature and then just follow the same process like I mentioned before. So there are two recommended ways here.
Thank you. Is there a way you can like post a link to like the documentation that shows how to do that?
Sure.
Yeah, she's going to talk about this now, actually.
Yes. So.
Or you wanted me to talk about the?
Yeah, I'm fine. Like, do you want to go?
No, go you.
Okay. So this is the AFNS 360 website, and you can find all the information that we covered in today's workshop here in terms of documentation. I mean, not in terms of the scripts, but in terms of documentation. So if you want to know what are the available, algorithms, what are the different types of, what is the parameter that you can provide, and what should be the input type. There is a documentation here which gives you detailed description of the input parameters, in which format it should be, and what are the different metrics and algorithms that's available, right? I have only like included maybe 10 or 15 of the fairness metrics, but if you actually see in this documentation, you can get the full list. I didn't include all the metrics. I have only few. So that's the first point I would like to cover. And then you have link to the Python R code. And I'm going to get into the resources part and get into the guidance. So this is where you have guidance on choosing the metric and algorithm. So I have covered different groups of metrics inside the toolkit, and also covered different algorithm and which algorithm to use in which scenario, right? So you can see the further consideration, which gives you clarity on, based on the notion of fairness, which algorithm you can choose, right? So you can basically look at the guidance material provided here to choose your metric and algorithm. So there's a glossary, which I really like, because the term can mean anything, right? Like it's not like universal. For me, like favorable label can mean different, and it may be different to you all, right? So there's a common glossary term which we like page we have. You can just quickly go through it, and when you actually match this with the documentation, you'll be able to understand better like what we are trying to convey. And here we have tutorials. We will also include the Python version. Right now we have links to the R version here. Sorry, we'll also include links to the R version. Right now we have Python version link here. So yeah, so we have tutorials in case we need to know more. And then this is a link to paper. If you want to know how the entire architecture has been set around the toolkit, right? And finally, we have this demo, web demo. Okay, I don't want to know anything about the components, but at least if you just want to know how the toolkit works, right? How the toolkit works on a high level, then this demo is the best. For example, let's say I'm choosing this data set. So this is what it does on a high level. It doesn't give you information about the components or metrics, but it's going to give you a high level overview of what the toolkit does. So it basically checks for the check for bias. It's going to tell you what's the race, which are the privileged, unprivileged group, and whether it's fair or if there is any bias. It's going to visually help you understand the concept. And then you can choose the mitigation algorithm. Let's say I choose reweighing algorithm. And then click on next. It's going to train. And it's going to give us the result, right? How the weights has been changed, and after changing the weight, how the metric has been updated. So this is like a visual, overview of the toolkit, and whatever we have covered till now is more about the components in depth. So, Gabriela and Stacey, do you want to add something to this?
No, that's great, Saishruthi. We have some call to action actually to you all. As you can imagine, this is a lot of work, this package, especially wrapping around the Python, because there are so many, dependencies that we use from the Python package that it gets tricky with the R version. So Saishruthi, do you want to just close it up with some call to action, and that we need all your help?
For sure. So again, this is one of the exciting parts in open source. Of course, you all we are going to create this together, right? This is not only 3 or 4 of us. We are going to work together and create this. So we have issues in our GitHub repository. If you can, let me show this. I think you can just show it in live. So if you go to the repository, if you go to the issue and filter based on the label R, you can see a bunch of issues where we have added, the requirements or the filling pieces. So missing pieces, right? Missing pieces that you want to fill. So each issue has a description of what is required under the particular ask. So and we will be available in case you don't understand the requirement here. So these are the open issues, and contribution is always welcome for all these issues, and we can work together and take this forward. Again, we have only 5 algorithms, and we have covered almost all the metrics here. But still, there are more work to do. For example, how to handle a multi-label data set, like multi-label data set, right? And how to handle regression data set, for example, regression model, right? So we have some gaps that we are trying to fill here, and everything is out in the issue. Feel free to connect with us, and let's create this together.
Awesome. Thank you. Thank you, Saishruthi. Thank you, everybody. Yeah, so again, this was a project that we found the need to create the R package for it. I had this idea, and I said, Saishruthi and Stacey, I need you to work with me because I'm not a Python expert. You are the Python expert. So they were, in the beginning, it's a fun story. In the beginning, they were crazy, like trying to understand this whole R syntax. This is so different from Python. And I'm like, yeah, it's so pretty, right? Anyway, so then they joined me in this adventure of trying to create an R package from the original Python package. So if you have any question, if you want to help us on taking this package to the next level, please do, and we would be very, very happy to see this evolving. So that's all. Thank you.
Thank you.
Thank you, everyone.
So thank you guys so much. So there's just one more question in the chat if you want to take a look. But I think we'll let you get back to Chase offline and wrap it up for today right on time. And we look forward to seeing you all back tomorrow morning. We will kick things off at 9 Central and then open up with a keynote by Dr. Price. And we'll have a 3 sets of divided track talks that are also going to be excellent tomorrow. So look for an email tonight from Ursa again with the Zoom link, and we'll look forward to seeing you all tomorrow.